Hey you guys, Miss Keaton's here, and this video is part 1. I'm going to focus on that first page, that front and the back, alright? That focuses on polynomial operations, multiplying, dividing, adding, subtracting polynomials, alright? So it says, given the functions of f of x is equal to x squared minus 3x minus 3, and g of x is equal to 2x squared plus 7 minus 2, find the following, alright? So it says find f of x plus g of x. F of x and g of x is just the name of the equations, the name of the expressions here. F of x is the name of x squared minus 3x minus 3. Because you're just so used of us saying y is equal to, which is fine. But when you have more than one equation, you start giving them names like f of x and g of x. All right, that's just the name of the equation. All right, because people are like, Miss Keaton, I can't find anything in my notes about f of x and g of x. You're right. We did not use f of x and g of x, but you know how to add like terms. You know how to combine like terms. So we are simply adding f of x and g of x. F of x is equal to, let's set it up. F of x is equal to x squared minus 3x minus 3 plus g of x is equal to 2x squared plus 7x, what's that, minus 2. And let me scroll up to just double check. 2x squared plus 7x minus 2. And we're combining our like terms by adding. So what are like terms? Like terms are terms that have the same variable and exponent. So you can only combine x squares with x squares. X to the power of 2 with x to the power of 2. So, for example, I'm going to use underlining. Usually you see me in class highlighting. I'm going to underline just so if you need a strategy to use yourself during your test and you don't have highlighters, underlining is a good tool. So here goes with x squared. X squared can combine with my 2x squared. Those are like terms. 3x, and note that I put 2 underlines here because that's a different term, that's a different variable. X squared is different from x. All right, 3x can combine with 7x. Those are like terms. Then negative 3 and negative 2 are like terms. So I'm going to combine my like terms here. X squared plus 2x squared, well, that's a 3x squared. And if you don't see a number in front of a variable, it's always 1. Negative 3x plus 7x, that's a positive 4x. A negative 3 plus a negative 2, that is a negative 5. And we combine like terms. We are finished. 2 says find g of x minus f of x. So we need to subtract g of x, which was 2x squared. Not minus, but plus 7x minus 2. Take away x squared minus 3x minus 3. So you're subtracting your like terms in this case. You're subtracting like terms, all right? Now I'm going to make this eraser smaller. Give me 1 second. So what you might be used to is always been told to distribute this subtraction sign. Everything behind this subtraction sign is getting subtracted. Why is everything behind it? It's the grouping. The grouping behind it is getting subtracted. That's why those parentheses matter. The grouping behind it. So everything behind it is getting subtracted. All right, so 2x squared combines with x squared. The like terms did not change in this case. You can combine those. The 7x with the negative 3x. And a negative 2x with the negative 3. Not negative 2x, that's just a negative 2. But a negative 3. So let me go ahead and distribute that negative sign. So I have a 2x squared plus 7x minus 2. Now distribute that minus, that subtraction sign. That's a negative x squared plus 3x plus 3. Let me go ahead and combine like terms. 2x squared minus x squared is a 1x squared, or you could just say x squared. You could just, once again, say 1x squared, or you could just put down x squared. Plus 10x plus 1. And you're done. 3 says to multiply f of x and g of x. So once again, f of x was that x squared. And actually, I'm going to give myself some space here. X squared minus 3x minus 3 times 2x squared plus 7x minus 3. Not minus 3, that's a minus 2. Forgive me, y'all. So we're multiplying. Everything in f of x is being multiplied by everything of g of x. Every single term in f of x is getting multiplied by every single term in g of x. So I'm going to show you 2 different methods here. The first thing is just distribute. First, distribute the x squared. All right, we're going to distribute the x squared to everything here. X squared, a 1x squared times 2x squared is a 2x squared, or not 2x squared, 2x to the 4th, excuse me. 7x times x squared, that's a 7x cubed. X squared times negative 2, that is a negative 2x squared. So we distribute that x squared. Now let's distribute this negative 3x to everything in the other parentheses. Negative 3x times 2x, that's a negative 6x. Negative 3 times 2 is a negative 6. X times x squared is x cubed. And we don't know how we got x cubed. Let's please review back exponent rules from unit 1, day 1. All right. Negative 6x cubed minus 21x squared minus 6x. And this is plus 6x because negative 3 times a negative 2 is positive. Then we have one more term to distribute. We're going to distribute this negative 3. Excuse me. Negative 3 times 2x squared, that's a negative 6x squared minus 21x plus 6. And now we're going to combine like terms. Once again, like terms mean they are the same variable with the same exponent. So there's no other 2x to the 4th, so I'm going to just bring down 2x to the 4th. I have a 7x cubed, and I have a negative 6x cubed. I'm going to combine those. That's a positive x cubed. Or you can say 1x cubed. I have a negative 2x squared minus a 21x squared minus a 6x squared. Negative 2 minus 21 is negative 23. Take away 6. Subtract 6. That is a negative 29x squared. I have a 6x minus 21x. That is a negative 15x. And that plus 6 doesn't have any like terms, so we bring down the plus 6. All right. So this is just one method. Other math teachers, or if you've been to tutoring, other math teachers use the box method. So let's create a box, right? And we know to find the area of a box, you do side times side. One side multiplied by the other side. Or even just the rectangle, right? Rectangle is length times width. Rectangle is length times width. So let's draw a box. Miss Keaton is a perfectionist, so forgive her. So we have one large box. Now let's take a look at how many terms are in each equation. F of x has 1, 2, 3. G of x has 1, 2, 3. So we're going to have 3 rows and 3 columns. 3 rows and 3 columns. Here go my rows. And here goes my columns. So what goes on top of the row right here is one of the equations. So we have an x squared minus 3x minus 3. What goes on the side of the rows is the other equation, which was a 2x squared 7x plus 7x minus 3. Always take the sign up front. And to find the area, you just do length times width. All right, 2x squared times x squared, that's 2x to the 4th. 2x squared times negative 3x, that is a negative 6x cubed. 2x squared times negative 3, that is a negative 6x squared. Now let's do the 7x. 7x times x squared, that is a 7x cubed. 7x times negative 3x, that's a negative 21x squared. 7x times negative 3, that is a negative 21x. Now let's take care of this negative 3 times x squared. That is a negative 3x squared. And sorry, y'all, this is a minus 2. It's 2x squared. Oops, forgive me. Right, because this is a 2, right? That's a negative 2, so forgive me there. 2x squared minus 7x, so I need to fix. Do I need to fix anything? No, I'm good. I'm still good. Okay. So negative 2 times x squared is a negative 2x squared. Negative 2 times negative 3x, that is a positive 6x. Then negative 2 times 3 is a positive 6. Then we're going to find our like terms. And guess what? Our like terms are diagonal. If you go left to right, they're diagonal to each other. Those are like terms. These are like terms. And we're going to combine our like terms. Combine them. So I have 2x to the 4th by itself. I'm going to combine my x cubes. That's 1x cubed. Combine my x squared. So that's a negative 29x squared. Combine my x's, that's a negative 15x. And that's a positive 6 at the end. Oops, 15x plus 6. And there we go, our answer. So that's just another method of multiplication. I'll show you again for 4. Find the area of a base of a rectangular box measured 2x squared plus 4x minus 3. Not find the area, but it's telling us the area of a rectangular box is 2x squared plus 4x minus 3. The height is x plus 2. Find the polynomial expression for the volume. So we have a box. We have a rectangular box. All right, let me draw it. It's a 3D shape. Hopefully, if you were in geometry last year, you remember that's the last thing we did in geometry was volume. Area, volume, surface area. So here goes my rectangular box. All right. And to find the volume is length times width times height. Well, guess what length times width is? Length times width is area. So we're going to do the area times the height. Area times height to find the volume. So we're going to be doing 2x squared plus 4x minus 3 times x plus 2. And I'm going to use the box method in this one, just so for those who want to use the box method, they see it again. So one of my equations, one of my expressions, 2x squared plus 4x minus 3, that has 1, 2, 3 terms. So you can either have 3 columns or 3 rows, up to you. But since I make my width long, I'm going to have 3 columns. 1, 2, 3. Then x plus 2, there's 2 terms. So I'm going to have 2 rows. Once again, what goes on the top is each term. So I have a 2x squared plus 4x minus 3. If you know how to multiply, you don't have to use the box method, but I'm showing it once again for my friends who will probably need another method. Then my other expression is x plus 2. To find the area of a square or a rectangle, we do length times width. 2x squared times x squared is 2x cubed. 4x times x is 4x squared. Negative 3 times x is negative 3x. 2x squared times 2, that's a 4x squared. Four x times 2, that is 8x. And 2 times negative 3, that is negative 6. Now we're going to find our like terms. And once again, they're diagonal left to right. So we're going to combine our like terms here. Our answer would be 2x cubed plus 8x squared plus 5x minus 6. That is the value of our rectangular box. So you don't have to use the box method to multiply. You can just simply distribute each term. You can distribute each term. But once again, I'm just providing additional methods. So 2x squared, multiply 2x squared by x, that is 2x cubed. 2x squared times 2, that's a 4x squared. Distribute the 4x, that's plus 4x squared plus 8x. Distribute that negative 3. That's a negative 3x minus 6. And you combine like terms. Forgive me, my pen stopped working. Considering the following functions, f of w is w to the 4th plus cw cubed minus 2w plus 4. And g of w is w plus 2. So they're asking us to combine like terms here. F of w plus g of w. Alright, so what I'm going to do is highlight my like terms. F of w plus g of w. Let's see. When I take a look, I have a negative 2w and a w. Those are like terms. I'm going to combine those. Now I have a 4 and I have a 2. Those are like terms, so I'm going to combine them. So what I have left is a w fourth plus 6w cubed. See, negative 2w plus w, that is a negative 1w. And 4 plus 2 is 6. Once again, we're just adding our like terms here. For b, I need to divide my expressions. So I have a w fourth plus 6w w fourth plus a 6w cubed minus 2w plus 4, all divided by w plus 2. So you learned two methods. We can do it by long division or we can do it by synthetic. I'm going to do this by synthetic. Synthetic is the easier right here. Since my divisor down here, and that's my divisor in the bottom, has a denominator of, not a denominator, my divisor has a coefficient, my leading coefficient, the number in front of w is 1. So I'm going to use synthetic here. So if you don't remember how to use synthetic division, here we go. So you have this little box. And in that box is going to be the opposite of this number, which is negative 2. Then everything to the right is going to have the coefficients, or the numbers in front of every variable right here. Every number, basically every number you see, you write down. So you have a 1w to the 4th. So we have a 1. We have a 6w cubed. We put down a 6. I'm missing a w squared. There is no w squared. So we're going to put down 0 for w squared. I have a negative 2w. Then I have a 4. Bring down the first number. That is a 1. 1 times negative 2 is a negative 2. Then we're going to add our columns. What's that? That is a, what is that? That's 4. Then the process repeat. 4 times negative 2 is a negative 8. Add your columns. Negative 8 times 2 is positive 16. Add your columns. 14 times negative 2 is a negative 28. Add your columns. And this last number will be your remainder. Our remainder is negative 24. So our final answer would be w cube, 1w cubed, plus 4w squared, minus 8w, plus 14, with a remainder of negative 24. So that's one way to write it. Another way you might see it in written for your remainder is a negative 24 over w plus 2. That's another way you might see it written. Simplify the following expression. 6x cubed plus 5x squared plus 9 divided by 2x plus 3. So I have to use long division here. I have to use long division. Synthetic division, but not sacrifice right now. We have to use long division. So once again, this is my divisor. The number around here is my divisor. We're going to put that outside the house. You see, I don't have an x term, so I replace it with a 0x. And we're focused solely on our x's. Focus on the x's. So we got to ask ourselves, what do I need to multiply 2x by to get 6x cubed? Well, 2 times 3 gives me 6. X times x squared give me x cubed. So my number right here is 3x squared. I'm going to multiply this 3x squared by 2x plus 3, which gives me 6x cube plus 9x squared. Then I'm going to subtract. That is a, negative 4x squared. Bring down this 0x. Now here we go with the x's again. What do I need to multiply 2x by to get a negative 4x squared? 2 times negative 2 gives me negative 4. X times x gives me x squared. So I'm going to multiply that negative 2x by my divisor right here. Negative 2x times 2x is a negative 4x squared. Negative 2x times 3 is a negative 6x. I'm going to subtract them. And that leaves me with a 6x. Bring down this plus 9. So once again, just focusing on my x. What do I need to multiply 2x by to get 6x? 2 times 3. All right. So I'm going to multiply 3 by this 2x here. 2x plus 3, 6x plus 9. I subtract them. And my remainder is 0. There is no remainder. Therefore, this is my answer. 3x squared minus 2x plus 3. All right, we have a few more problems to go. 4 more. Is t plus 4 a factor of 3t to the fourth plus 4t cubed minus 32t minus 5t minus 20? So basically this question is asking, right, if I divide 3t to the fourth plus 4t cubed minus 32t squared minus 5t minus 20. If I divide this expression by t plus 4, will there be a remainder? If there is a remainder, then no, it's not a factor. If there is not a remainder, yes, it is. So let's divide. And we can let's use synthetic division here. So once again, t plus 4 is my divisor. So I put a negative 4 in the box. Then everything to the right of my box are the numbers, the coefficients in front of my variables. All right, so I have 3. I have 4. I have a negative 32, a negative 5, and a negative 20. And all my variables are accounted for. I have a t to the fourth. Since I have a t to the fourth, I have a t cubed. I have a t squared. All right. So I'm going to bring down each one. Well, not each one. Bring down the first number, which is 3. Then we're going to do 3 times negative 4, which is negative 12. Add your columns. That's a negative 8. Negative 8 times negative 4. That is a positive 32. When I add my columns, I get 0. 0 times negative 4 is 0. Add your columns. Negative 5. Negative 5 times negative 4 is 20. Negative 20 plus 20 is 0. My remainder is always this last number. There is no remainder. So yes, it's a factor. There is no remainder. Find the remainder of 2x cubed minus x squared plus minus 19x plus 15 divided by x minus 3. So once again, I'm going to use synthetic here because this is a 1x minus 3. If the coefficient, if the number in front of your divisor is in front of that variable, let me repeat. In your divisor, there's a variable. If that number is a 1, use synthetic division. All right. If the number in front of that variable, in front of that binomial is a 1, use synthetic division. So right here, we're going to use the opposite of negative 3, which is 3. Then we're going to write down our coefficients here. We have a 2. We have a negative 1. We have a negative 19. So I have an x cubed. I have an x squared. I have an x. And I have a constant, which is 15. Bring down the first number, which is 2. 2 times 3 is 6. Add your columns, that's 5. 5 times 3 is 15. Add your columns, that's negative 4. Negative 4 times 3 is negative 12. Add your columns. The last number is your remainder. Remainder is 3. Rochelle used synthetic division to find the quotient of the following problem. X to the fifth minus 1 divided by x minus 1. Did Rochelle work the problem correctly? Why or why not? So let's set up ourselves. Let's use synthetic division. All right, so my divisor is x minus 1. So I'm going to have a 1 right here. I'm going to have a positive 1. Then I have x to the fifth. If you have an x to the fifth, that means you have an x to the fourth. You have an x cubed. You have an x squared. But you don't see those there. So we're going to just put zeros and replacement of them. So I have a 1 because there's an x to the fifth. I don't see an x to the fourth. I don't see x cubed. I don't see x squared. I don't see x. But I do have a negative 1. I have my constant. Bring down that 1. 1 times 1 is 1. You add your columns. 1 times 1. That's 1. 1 times 1 is 1. 1 times 1 brought down to 1. 1 times 1 is 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 1. When I add my column, I have 0. There is no remainder. So my final answer is 1w to the 4th plus 1. Oh, sorry. Why did I use w? This is x. Excuse me. 1x to the 4th plus 1x cubed plus 1x squared plus 1x plus 1. She did not solve this correctly. Why? Because she's missing a term. She's missing a term. She skipped a term. So the last one I'm going to do for this part of this video, which I know has been long. Alright, but it's good. And this is why I made a video, because I feel like we wouldn't have enough class time. Is find the value of k so that x minus 3 divides 2x cubed minus 11x squared plus 19x plus k with no remainder. Meaning I want a remainder of 0. A remainder should be 0. So I'm going to set this up using synthetic division. Find the value of k so that x divided by 3 divides 2x cubed minus 11x. And forgive me, my pen is giving out on me right now. 2. And I just bought this. And sole purpose to create this video. 2x cubed minus 11x squared plus 19x plus k, that's what we're trying to figure out what k is, divided by x minus 3, where there is no remainder. All right, so we're going to use synthetic division. We're going to set this up using synthetic division. So in my divisor, I have an x minus 3. The number I'm going to put in that box is a 3. Then I'm going to write down my 2. Forgive me, y'all. It worked so nicely at the beginning. I didn't think I was having this much issues. So I'm going to have a 3 right here in this corner. And everything to the right is going to be the 2. I have a negative 11. I have a 19. I have a k. Once again, I want my remainder, which is my last number, to be 0. All right, so let's use this process of synthetic. Bring down the 2. 2 times 3 is 6. Add your columns. Well, that is a what? That's negative 5. Negative 5 times 3 is negative 15. Add your columns. 4 times 3 is 12. All right, so k, some number plus 12 equals 0. K plus 12 equals 0. But when I subtract 12, k has to be negative 12. K has to be negative 12. For my remainder to be 0, k must be negative 12. And that's where I'm going to stop with this video. All right, thank you. And join part 2 for factoring.